difference between group item and elementary item. Example, group item, your name can be divided into first name, initial as well as last name. For elementary item, your USN, it cannot be subdivided, or bank passbook number, PAN card number, etc. cannot be divided. So it is called as elementary item. So data are organized into fields, records as well as files. Right now. So here there is one example. The employee of an organization, employee details, having the details of employee with respect to name, age, sex, then employee code, or the specific code which is given to each and every employees. That is called as a record of an employee. It can be stored with the help of special properties, or it are also called as attributes. Attributes are like name, age, etc. So if I say student detail, what are the attributes? Name of the student, the branch which he or she has selected, semester, section, right now, subjects, etc. are the attributes for a student. Then we have also studied entity set, as well as information. What is information? Data with the given attribute, or the data which is going to be processed is called information. Set of all the entities are called as entity set. Yeah, already I have given one example, right? Student. So attribute with respect to student is called entity set. Then field is the single elementary unit. Record is a collection of field values. Then file is nothing but collection of records. This is the example. How exactly the data is stored with the help of database, name, age, sex, USN, branch. Then classification of record. Record can be classified into two types. One is fixed length record, another one is variable length record. In fixed length record, what happens? All the records contain the same data items with the same amount of space allocated. Whereas in variable length record, file records may contain different length. For example, student records usually have variable length, right? Since the different students take different numbers of courses. Usually, variable length records have a minimum and a maximum length. Range of values, we can give range of values for the variable length record. Now, what is data structure? Coming to our important discussion, data structure. So, a data structure is a particular way of organizing data in a computer so that it can be used efficiently. I remember I explained some example in your first class. Why do we need data structure? What is the purpose of organizing the data in a structured way? Right? What is the reason? If the data is scattered here or there, it is difficult to use it whenever it is required. If we have a particular structure for the data, then it can be used or processed efficiently. Suppose you want to search for a given data. If the student information is stored in a particular manner with the help of USN and all, it is very easy to search the data. Right? In our college, we have one server, right? cells.vctputtur.vc.in, where the primary key is USN. With the help of your USN, we can access your data like in which semester you are studying, your phone number, your parents' phone number, etc. We can easily fetch. So that is the main use of better organization of the data. Or in the other way, we can also define data structure. It is a way of collecting and organizing data in such a way that we can perform operations on these data in an effective way. What are the different operations we can perform? As I told you earlier, insert the data. Suppose a student has entered into your class with the branch change, etc. Then you can insert him to your class. Then delete. Suppose a student leave the branch or the course, then delete the data, search the data, etc. are the different operations that can be performed on the data structure. Then, but for organizing the data, we have to consider these 2 points. What are the 2 points? The structure must be rich enough to understand real-world relationships. Means the structure in which you are going to employ, it has to, the people should understand the real world relationship. By understanding the real world relationship, we can organize the data. Then another way, it is another point, simple to process the data efficiently whenever needed. Structure has to be simple, as well as structure has to be rich enough to understand real world relationship. By keeping these 2 points in your mind, we can organize the data in an effective way. Now let us see how to classify data structures. Very important. With the help of this diagram, I will just explain you how exactly data structure can be classified. It is classified, go through the figure. You can see the arrow mark, right? Pointer, arrow mark, whether you can see this font?
Yes, ma'am. Yes, ma'am.
Okay. Data structure can be classified into 2 main types. They are primitive data structure as well as non-primitive data structure. Or in another way, if you go through Google, then you can also see 2 different types as simple data structure and compound data structure. Simple means primitive, compound means non-primitive. Now, let us see what is primitive and what is non-primitive. Primitive data structure used to represent the standard data types of any one of the computer languages. Okay. So primitive means basic data type. You already studied what are the different basic data types. What are the different basic data types? Like integer, float, instead of float, real is written over here. Int, float, character, boolean, etc. are the basic data types. Right? So primitive means the data structure used to represent the standard data type. Then what about the non-primitive data structures? Non-primitive data structure can be classified into 2 divisions, linear structure and non-linear data structure. Okay, data structure, primitive and non-primitive. Once again, in non-primitive, we have 2 types, linear and non-linear. Now, what is linear and what is linear? Let us discuss. Linear data structure, I have mentioned here, arrays, linked list, stack, queues, etc. Linear data structure can be constructed as a continuous arrangement of the data elements in the memory. This one you know, right? Arrays. Arrays will occupy continuous memory location. Right? Similarly, we have other different types, linked list, stacks, and queues. We will discuss later in the coming. In this module only, we will explain what is stack and queue. Actually, stack means a data structure where we can insert an element as well as delete an element from the same end, which is called as top of the stack. Okay, if you organize the books or the place in a structure in such a way that you can insert the books or the place from the top end as well as you can delete from the top end itself. If you remove the plate or the book in the middle, the organization may fall. Sometimes, not always, but with respect to stack, we can insert or delete the data from the same end, which is called as top. Okay, don't worry now. Just basic information is enough now. Okay, queue. Queue means it is related to our real world relationship queue. Right now, the data can be inserted from the one end and deleted from the other end, which is called as front of the queue and the rear of the queue. Front is the end where we can delete and the rear is the end where we can insert the data item. Queue system, right now, any ticket booking, reservation system, etc. If you go for a railway station or station. Okay, the station we are not going to follow the queue procedure in that, right? Okay, fine. So that is the example for queue. Then non-linear data structure. Okay, understood? No, linear data structure can be constructed as a continuous arrangement of the data elements in the memory, but it can be constructed by using array data type. Okay, in the simplest way, array data type. In linear data structure, the relationship of the adjacency is maintained between the data elements. We can apply some operations on a linear data structure like adding an element, delete an element, traverse, sort the list of elements, search for the data element, etc. Okay, easily we can apply all those operations. Now coming to non-linear data structure, what are those? There are two types, trees and graphs. I think about trees and graph we will discuss in the last module. Now, non-linear data structure can be constructed as a collection of randomly distributed set of data items joined together by using a special pointer or tag. Okay, pointer concept. Pointer is also not over for you, so I won't explain much about trees and graphs now. Just they are constructed as a collection of randomly distributed set of data items joined together with the help of a pointer. In nonlinear data structure, the relationship of adjacency is not maintained between the data items. They are scattered here or there. They are no need to be continuous also. That is called as trees or graphs. Understood, no? Classification. There are two main types, primitive and non-primitive. Primitive means basic data types, example in float, character, double, Boolean, etc. In non-primitive, we have two types, linear and non-linear. Linear, array, linked list, stack, and queues. For the linked list, we can allocate the memory dynamically also. Okay, for arrays also it is possible. Okay, let us see with the help of built-in functions like calloc or malloc. Then non-linear data structure, adjacency, relationship of adjacency is not maintained. Example, trees and graph. This is about classification. Please remember important topic. Now, let us discuss some points with respect to arrays. Okay, in last class we have discussed, but it is just the basic concepts. Only what is an array, what are the two types. This is the previous class. Now, some detailed discussion about the array. What is an array? As we all know, it is the simplest type of data structure, which is also called as linear array. Means items are arranged in a linear group one by one. They will occupy contiguous memory location. This is also called as one-dimensional array. Now, we can store a fixed size sequential collection of elements in the array of the same data type. If I declare an array of integers, we can store only integers. If I declare floating point array, then I can store only floating point data types. I can't change the data types in middle. Array is stored so that the position of each element can be computed from its index. Students, keep a notebook and pen with you. There are some problems to solve. Finding out the address of a particular array element. Okay, so please have a notebook and pen with you. Now, go through this example. Very simple to understand array concept. Okay, see how to declare array. I will put the syntax of array declaration, as you know already. Int. It is nothing but the data type. Int or float we can use. Followed by name of the array. Name of the array is array. Instead of array, I can use a or student or employee, whatever name can be given over here. Int is the data type followed by name of the array. What about this? Within the square bracket 10 means it is the size of the array. So we can store 10 elements at a time. So these are the elements which are initialized to this array. Okay, initialized values 35, 33, 42, 10, 14, 19, 27, 44, 26 and 31. 10 elements can be stored. Okay, now with respect to memory, just to see how exactly the array values can be stored. Element 35, this is the one possible memory location. Its index is 0. We can start the index from 0 or 1. It is left to the user. Usually, array index will start from 0. 0, 1, 2, 3. This index means the position. Are you following, students? Are you following? Arrays, index and actual values. A of, okay, array of 0 means 35. In the position array of 0, I have the value 35. Array of 1, which is nothing but 33. Like that, array of 2, array of 3, up to array of 9. In a particular memory location, the values are stored. Here, in this figure, we don't know about the exact memory location. How exactly it is stored in the memory, there is no reference, isn't it? We don't know which value, memory location value is assigned to array of 0. Okay, with respect to user, it is array of 0. With respect to computer's memory, we don't know. Okay, some address, maybe 100 or 1000, okay, whatever may be, it will be allocated during the runtime. Okay, fine. Now, array operations. What are the different operations that can be performed on the array? As I told you earlier, first one is traversal. Okay, traversal means accessing each record exactly once so that certain items in the record may be processed. Processing of the data, it is nothing but traversal. Sometimes we also call this traversal process as visiting the record. Okay, visiting the record or going through the record or just identifying the elements of the record, it is nothing but traversal. Understood now? Accessing the each record exactly once, it is called as traversal. So we can apply traversal mechanism to array. We can find out what are all the values stored in the array. Then second point is searching operation. Remember searching? Finding the location of the record with a given key value, or finding the locations of all the records which satisfy one or more conditions. In the previous example, if you want to access ninth element, then you can apply search operation. What is this? Which element is stored in the ninth location of the corresponding field? You can apply search operation. Or number you can enter the number to be searched. For example, 35. Then find out the location of the index, array index of that particular number. Here, enter the number that is done to be searched. Then you can apply the logic for finding out the position of the 10th element. Finally, as a result, you can display. We can find the element 10 in position 3. Okay, so that is the search operations. Then insertion. Insertion means adding a new record to the structure. So here, 10 now, for example, array size is 10. If you have only 9 elements, then one more position is left to enter one more element. Right? So at the end, also we can insert the element. That is easy process at the end. But if you want to insert an element in between, like fourth position, then we can apply some procedure. First, what we have to do, we have to keep this particular memory location free. 14 has to move one position towards the right. Right now, before moving to 14 towards the right, if you move 14 directly towards right, what happens? We may lose this value 19. Right now, 19 value 19 may be lost. So there are different steps to perform insertion. This one is clear now. Okay, only 9 elements I have. So last element 26 has to move towards right one position. Later, 7th element has to move to following right. So then, if I want to insert an element in the middle, then some of the operations I have to do. Move last element, last existing element, that is 26, to this position. 31 is not there, only 9 elements I have. 44 to here, 27 to here, this position, 19 to this position, then 14 to 19. After that, I can insert a new element number here. So let us study in detail what are all the array operations. One lab program is also there. At that time, I will explain with the help of code. One algorithm is there. Algorithm and program segment will be explained later. Okay, fine now. Yes? Respond.
Yes, ma'am.
Okay. Similarly, deletion operation. Deletion means removing a record from the structure. Okay, exactly opposite to insertion. Insertion, remove the element and that position must be filled with the remaining data. For inserting, we have moved towards right. For deletion, we have to move the element towards left. Sometimes two or more of the operations may be used in a given situation. For example, we may want to delete the record with a given key, which may mean we first need to search for the location of the record. Okay. For deleting a particular element, we have to search a particular location. So, the last two operations which are used in special situations. First one is sorting. Last two, sorting is the first one. Sorting means arranging the records in some logical order, maybe ascending order or descending order or alphabetically according to some name, etc. Then and the last one is merging. Merging means combining the records in two different sorted files into a single sorted file. Combining two different files into a single file is called as merging. And also we have some other operations like copying and concatenation will be discussed with the strings. Strings concept, we will see what is copying a string and what is concatenation of those strings. Okay, these are the different array operations. Now, array notation. Notation of the array. How to denote an array? As you all know, element of an array A may be denoted by how many notations? 3 notations. Okay. First one is subscript notation, means A1. This is the subscript. If I write 1 over here, it is nothing but a superscript, isn't it? So using subscript notation, we can denote the array A1, A2 up to AN. What is this N? Students, anyone respond? What is this N?
Size.
Size of the array. Okay. Fine. Another one is parenthesis notation. Means we are referring the elements of the array with the help of parenthesis. Okay. A followed by left parenthesis, then 1 means it is the index, first element, then close parenthesis. This is the another method. And third one is the bracket notation. Can you tell me which we are going to follow? First one or the second one or the third one? We are going to follow the third one. That is bracket notation, square bracket notation we are going to follow. But remember, these two are also okay, but this is the familiar and most frequently used. Now, the number k, as we all know, the number k is called subscript or the index. This one is familiar to us, right? Index. Okay, let us use index only. Instead of subscript, let us use index, array index. And A of k is called a subscripted variable or the value. A of k is the position where the element is stored. One example I have given over here. This is the student array. These are the indexes 1, 2, 3, 4, 5, 6. 6 student names are stored here. So instead of just 1, I can write student of 1 is equal to John Brown. Student of 2 is equal to Sandra Gold, etc. You can refer. Here, no. Now, length. Okay, listen carefully. Problems are there. Length of a linear array. What is a linear array? Linear array is a list of finite n of n, finite number n of homogeneous elements. As we all know, array is nothing but collection of homogeneous elements. So linear array is a list of finite number n of homogeneous elements. This n, number n of elements is called length or the size of the array. You know, n is the size of the array. So the index set consists of integers 0, 1, 2 up to n. Okay, you can also start from 1 to, but usually 0 to n. Then, what is the length of the array, or how many elements are there in a particular array, can be calculated using this formula. Note down this formula. Length of the array is given by UB minus LB plus 1. Can you imagine what is UB? Anyone? I didn't mention here. Just want to ask you. UB means?
Upper boundary.
Upper bound. UB means upper bound. LB means lower bound. Upper bound minus lower bound plus 1. This is the formula to find out size of the array. For example, one example I have given here, array of 6. 6 elements can be stored like this, array of 0, array of 1, 2, 3, 4, 5. Then the upper bound, what is the upper bound? That is nothing but this 5. Okay, 5. Lower bound is 0. So length is 5 minus 0 plus 1, which is equal to 6. If I start from 1, array index 1, then what happens? 1, 2, 3 up to 6. So 6 minus 0.
6 minus 1.
Sorry, 6 minus 1. 6 minus 1 plus 1, which is equal to 6.
6.
So size of the array is 6. This is how to calculate size of the array. It seems very easy now, finding out the length of the array. Now, let us find out the array index, where exactly a particular element is stored. That is nothing but linear representation of the array in the memory. How exactly the array elements are stored in the computer memory? Here, in this slide, you can see the memory location values like 1000, 1001, 1002, 1005, and just imagine dot, dot, dot. Okay, I will represent the memory from top to bottom here. Okay, depending upon the representation, you can have, the computer memory location from bottom to top or from top to bottom. So for simplicity purpose, let us use the memory location addresses like this. Okay, 1000. This is the position to store array element. Okay, maybe value 10 I can store here, 20 here, 30 here, something like that. So there are some points. LA is the name of our linear array now. LA, which is for linear array, or just A. LA be a linear array in the memory of a computer. So what is our name of the array? It is nothing but LA. Now the elements of LA are stored in the successive memory cells. That point also you know. If I store 10 here, next element I have to store here. Okay, with respect to array, elements are stored like that only. 10, 20, 30 in continuous order. The thing is, the computer does not need to keep track of the address of every element of array, but need to track only the address of the first element of the array, which is denoted by base address. Okay, see about addresses, memory addresses, what are different types and all. You study in CO, computer organization, what is base address, etc. So base address means the address of the first element. It is the base. What is the address of the first element with respect to this figure? It is 1000. Base address or the address of the first element, it is 1000. If you have this much data, we can calculate the location of, we'll go through this one now, location of LA of K. K means the index. Maybe the first one or the second one or third one, something like that. What is this? Address of the element LA of K of the array A. We can find out, the thing here is, we can find out the address of any element of the array. Okay. Suppose we have base address and which element we need to find out. Now, this is the formula. Please, students, please note down this formula. Everyone, formula to find out location of a particular element. Location of LA of K, which is given by base address, base of LA means base address plus W, right? W, I'll explain what is W, into K minus lower bound. K means this K, which index you, address of which element you are going to find out. That is K. What is W? It is nothing but the number of bytes or the word sometimes per memory cell for the array LA. This W depends upon the word length of the computer. Suppose word length of the computer is 16, then this W will be 2. Okay, 8 bytes will form a word. I don't know whether it is covered in computer organization or not. It is there. Okay? Word length, byte addressability, word addressability, little endian, big endian, etc. Okay, you will have a clear idea about this and all. But now I will tell you W means number of bytes per memory cell. Suppose your machine is of 16 bits, then W value is equal to 2. Suppose your machine is of 32, then W value is of 4. For example, let us discuss the problems now. Okay. See, now very simple 8-bit machine. Let us consider 8-byte machine. See, for example, if your computer's word length is 8, then elements are stored in this way. Memory location 200. This is the position to store LA of 1, first element. 201, LA of 2 is stored. 202, LA of 3 is stored. Okay, like that. So in this case, each element of the array occupies 1 byte. Okay, 1 byte, 1 element. So how to find out the address for LA of 6? There is a formula, right? Location of LA of K is given by base address, base of LA, base address plus W into K minus lower bound. This is the formula. Are you following? Note down. Write this figure. I will give you time. Write down the question. Find the address for LA of 6. Find the address of LA of 6 for this snapshot. See, the elements which are stored are not important now. For us, finding out the location is important. Okay, question clear? Are you writing, students? Yes or no?
Yes, ma'am.
Okay. This one over. Snapshot. Note. Then write the formula. Location of LA of K is given by base address plus W into K minus lower bound. What are the values to be substituted? Values. LA of K. What is this K value? It is nothing but 6. Right? LA of 6 we need to find out, which is equal to base address, means the first address, that is 200. Base address is 200 plus W value, this one. Each element of the array is occupied 1 byte. So W value is 1. K is 6 minus lower bound. Lower bound is 1. 1 into lower bound. So 200 plus 6 minus 1 is 5. 5 into 1 is 5. So 200 plus 5 will give you 205. Now just to observe, 205 is the address of LA of 6. You can verify using this figure. One more question I will add. Find out LA of 15. Okay. Next question using this figure only. LA of 15. I will mention the name. If you answer, I will give some time to calculate. LA of 16 you need to find out.
214.
Over. 1 minute.
Yes.
Aditya. Are you there? Aditya M.
Hello.
What is the value? 200 plus. Hello. Yeah, I am hearing. 200 plus.
Hello.
Yes, hello.
Yes, ma'am.
15 given, no? 15 minus 1.
40.
Value is 200 and
202.
2. How it is 202? It is the address of second element. Third. Anyone else?
214. ma'am.
214.
214.
Enough. Okay, 214. 200 plus
14.
here 1 into 14 minus 15 minus 1. So 200 and should I write it? No need, right? Here 15 minus 1. So 14. So it is equal to 214. Okay, now let us move next problem. This one. Take down example 2. W value is different here. Find the address for LA of 16. Find the address for LA of 16 for this snapshot. See, suppose this is not given, students, try to understand. Suppose this is not given. Will you able to understand by using this figure what is the value of W?
Yes, ma'am.
Yes, right? LA of 1. 2 cells means LA of 1. Next to 2 cells, LA of 2. Okay, so W value is 2. Each element of the array occupy 2 bytes. Base address is 200. One problem is solved. And one more I will add after this. So here, you can write down. Answer your attendance. Adesh. Adesh present, no?
Yes, ma'am. Present, ma'am.
Adarsh. Adarsha, AP. Aditya. Advit.
Present, ma'am.
Present.
Akia.
Present, ma'am.
Ajay Kumar. Ajay.
Yes, ma'am.
Akshay.
Present, ma'am.
Amrita,
Present, ma'am.
Anisha, Anisha D. Anish, Anusha,
Yes, ma'am.
okay, Anushri,
Present, ma'am.
Bhavana,
Present, ma'am.
Chaitra DK,
Present, ma'am.
Chaitra NJ, Shetan,
Yes, ma'am.
Deepika,
Present, ma'am.
where is Chandan? Chandan, you can't see. Chandan KS. Chintan, Chiral, you can't see. Deepika, Devadatta, Devi Prasad, Dhanu.
Present, ma'am.
It's okay, okay. I will see there. Dhanya,
Present, ma'am.
Dhanyashri,
Present, ma'am.
Devashri,
Present, ma'am.
Divyashri, Fatima, Shamna,
Present, ma'am. Present, ma'am. Present, ma'am.
okay. Suzana and Ajmir, are you there? Suzana and Ajmir, can't see now. Okay, are there? Please know later. Hardik, Hemant, Swati, Swati, are you there? Janavi, Varun,
Yes, ma'am.
Yashwant,
Yes, ma'am.
Samhita, Karthik, Kaustuba, Kavyashri, Ketan,
Present, ma'am.
Present, ma'am.
Present, ma'am.
Deepika,
Present, ma'am.
Harit, Mahima, Megha, Namita,
Present, ma'am. Present, ma'am.
Present, ma'am.
okay, Nikhil, Nisarga, Nisha.
Present, ma'am.
Present,
Present,
ma'am.
ma'am.
Over, problem statement. Now, should I explain this one? Base address is 200 plus W value is 2 into 16 is the thing which you are going to calculate minus 1, which is nothing but our lower bound, which is equal to 230. 16 minus 1 is 15. 15 into 2 is 30. 200 plus 30. And this is just a note. Given any value of k, time to calculate location of the LA of k is same. Okay, this is with respect to efficiency of computer and all. It doesn't matter value of k. Now, can you calculate LA of 30? With fast LA
Yes,
of
ma'am.
30. 30 means by just doing mental calculation also you can say
258.
30 means 29. 30 minus
258.
1 is 29. 29 into 2,
258.
8. 200 and
58. 258.
58.
okay. Now understood. Now,
258.
oh, fine. Now there is a homework. Take down this. What is W value?
4.
4.
4.
Four.
W is 4. Okay.
Two not 8.
Find the address for LA of 3, LA of 12, and LA of 19. Do it now itself, okay? Because next one topic is about structures and union. So better to start from the next class only. You'll be fresh at that time, right? So do it now itself. Class work on.
208, 244, and 272.
Too fast you are.
208, 244, 272.
1 minute, we see. Just mention your name, students, okay? Who is answering? Just mention your name. Is it Naveen?
Yes, ma'am.
Who first answer? Varun?
Varun, ma'am.
Varun, right.